Okay, so we're back with the problem 2 solution. I hope that you tried to solve problem 2 on your own. If not, this video comes with a special virus installed that will determine if you have paused the video and attempted to solve the problem on your own, and I will know. Did you try? Don't lie to me. Okay, so I've drawn this picture again because having a picture is helpful. You can see that I've made angles B and C really tiny because they're tiny angles. And angle A is clearly the biggest angle in this triangle. The first thing I did was the easiest thing. I found the measure of angle A, and that's 131.8 degrees. Now, since angle A and side A make up my pair, that is one complete fraction, I'm going to stick with using that in my other calculations to find side B and side C. I found side B first just because B is first in the alphabet. So I set up my proportion A over sine A equals B over sine B. So that's 315 over the sine of 131.8 equals B over sine of 13.4. Same thing I did before. I said, well, my variable is B, or my unknown is B, and so I'll multiply both sides by the denominator of that fraction. And I did that, and I used my calculator, and I got that B was 97.9 centimeters. So I look and I say, does that make sense? Well, B is pretty small angle, so it makes sense that the side is much shorter. Okay, moving on to the final part in solving this triangle, I'm looking for my third length. That's the length of side C. Once again, I've noted I'm using angle A and side A in my proportion A over sine A equals C over sine C. Yes, if you want to, you can use B over sine B instead of A over sine A. The reason I don't use it is because if I've made a mistake in finding the length of side B, then that mistake is going to carry through, and it's going to make me get a wrong answer with the side C as well, and I would prefer to have as few wrong answers as possible. My procedure works exactly the same. The only thing that's going to look different here is I'm using the measure of angle C in the denominator of my second fraction. But I multiply both sides by that denominator, I use my calculator, and I get an answer of 177.2 centimeters for side C. And to me, that looks pretty good. C is the middle-sized angle, and as we recall from the triangle inequality theorem, the shortest side is across from the smallest angle, 97.9, across from little angle B. The middle side is across from the middle-sized angle, 177.2 was across from middle-sized angle C, and the largest side at 315 centimeters is across from that really big obtuse angle A. So that's two examples of using the law of sines to solve a triangle. Now I have 3 questions for you that I want you to come into class prepared to discuss, and here are those questions. First, what would be different about the way the problem was set up if we were having to solve for an angle measure in our proportion? How might that look different? So something to think about there. Secondly, how could you check that your answers are correct? This is not a right triangle, so we can't use the Pythagorean theorem to make sure that the sides match the Pythagorean theorem. So what other ways do we have to check and make sure that our answers are correct? And finally, I'd like you to write your own problem that can be solved with the law of sines. And of course, you should solve this problem and demonstrate that you know how to solve it. If you have any questions, be sure to bring them into class the next time that we meet, or stop by before class and let me know. Thanks, and have a great night.